Hi everyone, in this video I'm taking a look at this proof question which says if A on B equals B on C equals C on A, then prove that A is equal to B which is equal to C. And what that's really saying is that these three fractions must all be equal to 1, since A over B means A divided by B, and if A is equal to B, then any number divided by itself must be 1. And that's true for the other two fractions as well. So to get started, I'm going to let each of these fractions be equal to some constant. So we'll say let A over B be equal to some constant k, and I don't know what k is, but I know it's some number. But B over C will also be equal to the same constant since those fractions are equal. And finally, C over A will be equal to that same constant. And now rewriting the original equalities in this format, we're left with three equations and effectively three unknowns, being A, B, and C. And if we use the technique of simultaneous equations, hopefully we are able to then get to the point where we prove that those three unknowns, A, B, and C, must all be equal to each other. So to get started with the simultaneous equations, I'll define each of these three equations as equation 1, equation 2, and equation 3. And I'm going to start by taking equation 1 and dividing it by equation 2. So let's say equation 1 divided by equation 2. So if I start with the left-hand side, equation 1, the left-hand side was A over B, and that's going to be divided by B over C. And the right-hand sides will be K over K. So now if I clean this up, with the left-hand side, we're dividing one fraction by another. So we will keep the first fraction, we will flip the second fraction, and we will change from dividing to multiplying. And on the right-hand side, we've got K divided by K, which is 1. So cleaning that up a little more, A times C we can write as AC, B times B we can write as B squared, and that will be equal to 1. And then I'll multiply both sides by B squared, and I'll be left with AC equals B squared. And that I will call equation 4. And we will park that for now. What we'll do as the next step is we'll take equation 1, and this time we'll divide it by equation 3. So let's take equation 1 divided by equation 3. So equation 1, the left-hand side was A over B, and that's going to be divided by the left-hand side of equation 3, which was C over A. And once again, that it will be equal to K over K. So again, we will keep our first fraction, we will flip our second fraction, and we will change to multiplication, and that will be equal to 1 since K on K is equal to 1. So here we can say A times A is A squared, and that is divided by BC, and that's equal to 1. And I'll multiply both sides by BC, and I'll be left with A squared is equal to BC. What I'd really like to do is be able to substitute something into equation 4. So what I might do is I will make C the subject. So I can just flip these around and write BC equals A squared, and then I'll divide both sides by B. So I'll be left with C is equal to A squared divided by B, and that I will call equation 5. And what I will do is I will substitute equation 5 into equation 4. That will eliminate C. We'll get some new equation in terms of only A and B, and then that we can substitute into any equation we like, and that should leave us with the result that we need. So I'm going to take equation 5 and substitute it into equation 4. So sub 5 into 4. So what that means is if I go to equation 4, wherever I see the letter C, I will instead write a squared on b. So that will become a times c would become a times a squared on b. And that will be equal to the right-hand side of equation 4, which was b squared. So cleaning that up, a times a squared would be a cubed, and that's divided by b, so that's equal to b squared. I'll multiply both sides by b, and I'll get a cubed equals b cubed. And if I take the cubed root of both sides, I would end up with a is equal to b. And so that's the first part of what we're trying to prove. We're trying to prove that a is equal to b, which is equal to c. I know that a is equal to b, and I will call that equation 6 we're up to. And now I can sub equation 6 into, let's go with equation 5. We could really pick any equation we like, but if I go with 5, equation 5 said c is equal to a squared on b, but a is equal to b. So I can, instead of wherever I see a, I'll just write b. So c will be equal to b squared on b. And b squared divided by b would leave us with c is just equal to b. And if we know that a is equal to b and that b is equal to c, then we can conclude that a is equal to b is equal to c, which is what we were asked to show. So hopefully that makes sense, and you've been able to follow along. So in the end, we were able to prove this result. If a on b equals b on c equals c on a, we could prove that that means a is equal to b is equal to c using the technique of simultaneous equations. So hopefully you found that helpful, and tick boom. We bring the boom!